If you have ever washed a spoon, you will probably have noticed that the water sometimes deflects off the spoon into a dome-shaped flow. In this video, I'm going to attempt to explain this phenomenon. In this video, I will show you a demo of the flow phenomena that I am talking about. Then I will give you a brief intro to laminar flow and streamlines. Then I will show you some sketches of the faucet flow deflecting off the spoon, as well as show you some simulated results of laminar flow around a spoon. And then I'll give you some brief conclusions and recap of what we learned. Let's watch the demo of the flow phenomenon. Water from the faucet deflecting off a spoon. Okay, so what is laminar flow? Well, laminar flow is a smooth, steady flow with low Reynolds number and with parallel streamlines. Usually in Intro to Fluid Dynamics, we learn that laminar flow occurs at low Reynolds numbers, but sometimes we don't really talk about streamlines. This is also very important. It is imperative that we have parallel streamlines in laminar flow. The more parallel, the more laminar the flow. Okay, and what is a streamline? Well, a streamline is defined as the line drawn tangent to the velocity vector at each point in a flow field, or mathematically defined as shown here in this slide. Here I'm showing you my two best attempts at sketching the flow of water coming out of the faucet and deflecting off a spoon. We can see that coming out of the faucet, we have parallel streamlines in the flow, and that they deflect geometrically according to the shape, in this case, an approximation of a spoon. Please note that the streamlines are supposed to be approximately equidistant from one another. Sorry for my terrible artistic skills. As an engineer, I wanted to do a more quantitative analysis. So I found an open source code that solves the 2D Navier-Stokes equations. The code was originally written by Jamie Jones. I edited and adapted the code to simulate a spoon inside an incompressible flow. The red is supposed to represent laminar incompressible flow. The green is simply the outlet of the flow, and in black I have the approximation of a spoon. In the simulation that I am about to show, you will see how the incompressible flow simply deflects around the object and continues to be mostly laminar. Alright, now let's look at the simulation carefully and let's look at how the flow develops. Let's look at it a few more times to fully appreciate it. The yellow colored flow in this simulation basically represents or simulates the phenomena that we see of the water flow deflecting off a spoon. In conclusion, water from the faucet deflects off a spoon into a dome-shaped flow when the water flow is sufficiently laminar so that the streamlines simply bend around the spoon. Laminar flow is not only about having a low Reynolds number, but also parallel streamlines in the flow are an important characteristic of this flow.